and live. Dose and double. Okay, limiting reagent, limiting reactant. I use the reactant and reagent the same. I use the term limiting reactant and reagent interchangeably, synonyms. A reactant's on the left-hand side of a chemical equation, right? It's your starting material. So, reading through this, because I'm not using a ton. In a chemical reaction, an insufficient quantity of any of the reactants will limit the amount of product that's formed. Okay. The limiting reagent is the reagent reactant that determines the amount of product that can be formed by a reaction. The excess is the reactant that's not completely used in this reaction. Thus, there is some of this reactant left over. Now, just think about this. If you were making chocolate milk by the cup or whatever, and you want to have 5 cups of chocolate milk, you got a gallon of milk, and you had a little bit of squirt bottle, like, I'm just using this, and it's gross or not. If you had a little squirt bottle with only, it was like almost empty. You wanted to make 4 chocolate milk glasses for you and 3 other people. I think you know that you'd be limited not by the milk, but by the amount of chocolate syrup, right? Whether it's gross or not, that's different. And I do agree, bought chocolate milk is better than chocolate syrup. Now, just taking a look at this example, it's pretty easy to understand, because we do understand this with fruit. Which is limiting and which is in excess. And this, as a shopper and stuff like this, I hate this. The hot dogs I buy by a particular brand, Harvest, and they come in packs of 10. And buns come in 12. Now, so this is an example that really hits home for me. Which is in excess, which is limited. Well, this is fully out. 1, 2, 3, 4, 5 hot dogs. 1, 2, 3, 4 buns. You know you're going to run out of buns before hot dogs in this case, right? That means you can make 4 hot dogs, and the excess would be the 1 hot dog. When I say hot dogs and buns, fully correct. So underneath here, what is the hot dog considered? The limiting or the excess reactant? The excess reagent, limiting. Which one is it? Limiting or excess? You got more than enough. So I want you to write excess there. Yes, mine color yours. So the bun is the limiting. It determines how much you can actually. This is theoretically, I'm putting down theoretical yield. In theory, you should be able to make 4 complete hot dogs to serve. And the excess reagent, the excess reactant that's left over, again, 1 bun extra. Or 1 bun extra, I said it, 1 hot dog. In real life, for me, it's always the other way around. I buy 10 hot dogs, have 12 buns. I just don't eat hot dog buns unless there's a hot dog in. Sometimes I'll like pretend it's a hot dog. And you guys like peanut butter and pickles? Get really big pickles, put them in a hot dog bun with peanut butter. It's delicious. Recommend. Peanut butter pickle sandwiches are awesome. So that's what you do with your excess hot dog. Okay. Take a look at this then. Making grilled cheese sandwiches. Oh, which is limiting, which is in excess in this case. Wow, I just can't do anything right. Okay, back to this. I got 2 slices of cheese, and I got 1, 2, 3, 4, 5, 6 slices of bread. I think we understand 2 slices of bread per sandwich, 1 slice of cheese. Now with all of this, which one are you going to run out of? They run out of cheese. So we would call that the limiting or excess. Limiting reagent, limiting reactant. Okay. I'm going to write that one. I'm going to put reactant down just for a change of words, just so you're familiar with both phrases. And then, obviously, then the bread is the excess, and there's two slices of bread left. Okay. So I think this is a relatively simple concept. Until we start getting mathematical and all, chemistry of grams and moles. Well, it's still simple, but this is the actual concept. Does everybody understand? I think the word excess and so let's move it on.
Really have to write limiting reaction or just like limiting?
Depends on what you're limiting, reagent or reactant. Yeah. Okay. Now, this will make more sense as you do them, but keep this in mind. So I'll run through this, and then we'll actually do some examples. The first thing you do is I will give you two amounts of a reactants, reagents. You're going to convert both reactants to moles. Then you've got to see if all of one of the, just choose one randomly, if all of the moles of this reactant reacted, how much would you need of the other? And then just make a comparison and see do you have that amount or not. Then you'll be able to say, okay, this one runs out, that's limited. You can actually see how much is produced. So I don't think you're memorizing this, and I don't think you need to memorize this. These are the steps we're going to take as we do an example. Convert to moles, figure out how much you need of the other reactants based on. Okay, so flipping ahead. So the example we're going to look at is this copper reaction. Copper reacts with sulfur to form copper 1 sulfide according to this reaction. Okay, let's switch. What is limiting? What's the limiting reactant reagent? Like 80 grams of copper reacts with 25 grams of sulfur. How many grams of copper 1 sulfide can be formed? So this is a typical question. We've got information given about both reactants. It's essentially just an extra step in our previous problems. So we set this up. Find moles. We'll just say step 1. Now you don't have to label these, but I'm referring to those steps that we had on there. This is what we're doing right now. And I see 80 grams of copper. So I'm going to start with 80 grams. And of course, we use periodic table. Copper, 62.55. And we use a calculator. I ain't doing this in my head. Because I know it's over 1. 80 divided by 62. I get it 1.258, blah, blah, blah. I'm going to call it 1.26. And that's moles of copper. The other chemical is 25 grams of sulfur. And according to this reaction, I copied and pasted this. It really should be S8, but it isn't. So we're using S because that's single S. 1 mole, 32.07. Yeah, 32.07. 25 divided by 32.07. 0.6
79795. 7795.
3 digits, 780.
Okay. That's what we're starting with. They're not all going to be used up unless magically they're the exact same amount. Mole-wise, that we perfectly need. So, step 2. If you recall, step 2 was take one of the reactants and convert it to moles of the other. So, it doesn't matter which one you choose. I'm going to just go with copper because I listed it first. I say it's 80 grams, or not 80 grams because I've already converted it to moles. 1.26 moles of copper. I'm going to convert it to sulfur, but I'm going to look at the equation for the balancing numbers. It's already balanced. There's 2 copper to 1 sulfur. So if I do this, when I stop right now, what it is if 1.26 moles of copper fully reacted, how much sulfur do we actually need? So I take my calculator, which I can do that one. 63. 120, 60 again. 126, 0.630 moles of sulfur. This is the amount of sulfur needed for all of that copper and triage. So, do we have this amount of sulfur? Yes, we have 0.78 moles of sulfur, right? So, you guys see, and I just randomly chose it. I could have chosen copper and it would come out the other way around. But we see that we have more than enough sulfur. That's an excess. So I put, therefore, I'm going to make a statement right now. And by the way, you ever see 3 dots to mean therefore? I'm going to just put that in brackets and then I'll use that from now on. That's what I'm saying there, just in case you're not familiar. Therefore, I'll put that every other time. S is in excess. Copper is limited. Okay. We need to figure that out. You understand the logic behind that? I'm going to just do a little aside. I'm going to put this down. Not needed, but I'm going to show it this time more. But here we have started with, well, for this step. Okay? How would we have figured this out? Well, we would have said 0.780 moles of sulfur. And then we say, well, I want to get rid of sulfur. Figure out if all of the sulfur could react, how much copper would we need? I doubled that, so 156. That's how much copper would be needed if all of that would react. Okay, so then you'd ask yourself, this is if you didn't use copper first, just by running. Would never do this if you already figured this out. But here's the logic. Do you have that amount of copper? No. So obviously you have more than enough sulfur. Does that make sense? Okay. But I can stop anyways. Same conclusion. Therefore, S is X. Okay. You still come to the same conclusion, but sort of opposite reading. All I'm just showing how it would work. I'll just box that off a little bit. Like I said, not needed, but if it's started. Okay. We know it's limited. It's copper. Continuing on. What will we ask for, I guess? In this case, how many grams of copper one sulfide can be formed? Always use your limiting. So. Always use the limiting reagent to find the amount of product made. I see I missed that off. I'm finding. So we only have 1.26 moles of copper, so I'm going to start with that. And since I've already changed it to grams, I'm going to just start with moles. One less. You know, it's a 1 to 2, 2 to 1 ratio, whatever you want to say. You're going to have 2 coppers, 1 salt. Oh, just a second. Which one did we want? Sorry. Oh, yeah, the copper. It's a 1 copper. Copper 2 salt. It's kind of messy there. But anyway, there. So at this point, if I stop, you have moles of copper 1 sulfide. Copper 1 sulfide. We want to find the mass, though. So I've got to add that up. 1 grams. 2 coppers. 1 sulfur. 2.07 plus 159.17. Okay, got that. Use my calculator. $100.2771. Well, I'm going to use just 100, but that's ambiguous. I'm going to just show you what you do, scientific notation, so that I know for sure this is 3 digits. I'm only doing this because it goes back zeros you never should. Clark, what is it? What do you want to do? Grams.
Reaction.
Reagents.
Oh.
Limiting reagents. Oh, good. Don't take them right now. This is a long time using it. Okay. So that's how much is. Any questions about something like this? Because I'll have more questions. I mix up the numbers. No, because I make a lot of mistakes. I didn't see those. Keep asking. Want this money? Okay. Anyone? Questions, other questions? And flip. Flip her out. Don't flip out on me. Actually, do flip. For example. A little extra on this one. Here's a reaction. Got an organic molecule. Fe plus oxygen, CO2, carbon dioxide, and water. It's balanced. We don't have to worry about that. But the first thing you should always check is the equation balanced? It is. Okay. In this case, some of the work is done for you compared to the last one. It's already in moles, so we don't have to do convert to moles as our first step. Okay? So sometimes I can give you one in grams and one in moles too, so you don't have to convert one. Identify the limiting reagents, calculate the moles of water produced, and how much excess is left over. The limiting will always be used up 100% theoretical. Okay? So since they're in moles already, just choose one and see how much of the other you need. Which one, and I'm just going to go randomly, which one do you guys want to just choose? The C2H4 or the O2? C2H4 is listed first. I probably would have. So I'm going to go with 2.70 moles of C2H4. And I'm trying to figure out if all of the C2H4 reacting, how many moles of oxygen are needed? Well, I'm going to use the balanced reaction. We've got one C2H4 every oxygen mole. So doubling that up, and I can do that one in my head, 5.4 moles of oxygen needed. So we ask ourselves, do we have enough oxygen? Will we run out of oxygen? Will we run out of C2H4? We're going to run out because we have more than enough oxygen. So to answer that, the limiting is C2H4. I use the word reagent and reactant interchangeably, just so your vocabulary-wise you're used to that. I think we know the word reactant quite well. So I'll start to use reagent a little more, just to get it. Okay, this is good to know. Calculate the moles of water produced. I don't need grams, with a little less work. Grams is just an extra step. So we're working in moles exclusively. Okay, so here's, I'll just kind of put a star beside this because this is one of the things that was up. The next thing is calculate the moles of water produced. We always use the limiting. So we're going to do that. 2.70 moles of C2H4. Getting rid of that, I want moles of water. Look at the balanced reaction and see that it's two waters. Find out same digits as above, so it's 5.40 moles H2O produced. I'm going to circle that because that's something, or star, whatever, it's something your teacher is looking for. Okay? Then, how much excess reagent is left over? hopefully this is just a contract. Excess reagent left over. Well, we can see from above, we're only going to use 5.4 moles of oxygen. Sometimes you get to this step and it's random which one you pick first, right? And you'll find out, gosh, I still don't know that. You'd actually have to calculate the other way around. In this case, we were lucky. Yeah. So we're going to say we started with, what was it? 6.30 moles of oxygen. So if you have 6.30 moles of oxygen, you're going to subtract off the amount used. I'll put it in green so you know what kind of where it came from. And this is just simple subtraction. 63 minus 54 is 9, so 0. That's our third answer. The extra steps of mass and mass or big mass, but we know how to go from grams to moles. It's the same with water. Well, should we get you to try some on your own, or should I go through another example? I don't know. What? He says example, other people? Okay, we're outnumbered by others. We'll do one last example. Are you going to save it for tomorrow? Okay, this is similar to the other reaction. H, let's call that line, plus oxygen, carbon dioxide, and water. It is balanced. 2:5 ratio to the reactants. How many grams of water can be produced by the reaction of 2.4 moles of ethine, C2H4, 7.4 moles of oxygen? So we just randomly go with the first one given? Okay. It doesn't matter if I go with 7.4 moles of oxygen or not, or the 2.4, but I'll go with 2.4. Now it's already converted to moles, so that step is done. Everything's in moles. Otherwise, you'd be doing that right off. And I say, get rid of C2H+. So two groups of C2H2, I simply. Accident. There's 5 oxygen required for that 5-to-2 ratio. Oh, I can do this. 24 divided by 2 is 12. 12 times 5 is 60, so 6. Thank you. Ask ourselves, do we have 6 moles of oxygen required? Oh, we have 7.4. So, I'm going to just do it like this. This is the limiting. Keegan had asked earlier, I guess you're right. We could just go with limiting off of it. This is in excess. Depends on your sentence structure. Okay, does that make sense why one's limited, one's... Yeah. Once you do that, any calculation of a product has to be done using the limiting reagent. So, taking a look at this. Grams of water. So I want H2O. So I'm going to set up a ratio. I'm going to start with 2.4. It's the limiting. And say, well, 2 groups of C, 2 waters. I did it in green, I usually do that in yellow. I don't think it's cute. Oh well, I'll just keep it there. Yes, it is. I'm gonna just erase it anyway then. Because I screwed up. I'm still thinking about the last problem. Can't get that problem off my mind. So what was it? Two groups of C2H2. I think it makes two waters, not, yeah. Two waters. Okay, if I stop calculating right now, I have moles of water. I think I solved it. Nope, I have 1 gram. So 1802, I've done water enough to know that. But you'd use it periodically. Now I'll have mass of water. By the way, 2 over 2 is just 1. Right? So I don't have to enter it in my calculator, but you can put times 2 above it. 2.4. 43.248. Doesn't it? This is called 43.2. Okay, does this solve the problem? We weren't asked to calculate the amount of excess. We could. We didn't. We're just asking the grams of water produced. There's all sorts of ways this problem could be asked. Now I am going to give you some questions. I'll hand them up in a second. Any questions before we do?